the America Makes Virtual Game Day series. Hey, Erika, thanks for joining us. We want to now bring on John Wilsinski. While he comes on board, Link3D is the digital sponsor for this event. We are an additive workflow software company, and we're really excited to partner with us to help connect not only the digital thread, but the digital community. Hey, John, how are you doing?
I am wonderful. How are you, Janet?
Wonderful, wonderful. I hear you have a lot of interesting and exciting things to share with us today. So I will leave the floor to you.
We've got a couple. So we'll start with those. So you can see on the screen right now. Well, first of all, thank you all for joining. Really excited to continue this game day series. Here we're focusing on a variety of different topics. We've hit everything from supply chain to where is additive manufacturing going, but we're really excited to be bringing this AM intersection with athletics topic. So it's something that it's relatively new for us. We've hit on individual speakers here and there over the years, but this will be the first time we've really focused on it. So really excited to see what the speakers have to say. Therefore, I won't take too much time getting this thing started, but I did want to make everyone aware, so we're trying to continue to bring content to the community in a variety of different formats. So many of you at this point are familiar with our game day series. We're going to continue doing those. It's somewhere where we're trying to get topics out to the community that maybe don't fall directly in the swim lane of one of our technical reviews or into MMX or something like that. So our plan is to continue doing that over calendar year 21. And we're excited to be announcing this mini TRX, as we're calling it. It will be on December 10th. It is going to be picking up and continuing the conversation around standards. And it will, as I said, take place December 10th. Registration is actually open. I just see Tara just posted the link. So encourage you to go out and register for that. It's about a day of content. There's a variety of different speakers. There's going to be updates from some of the different standards bodies, as well as a number of different technical talks, including some project out briefs. There's a couple of programs that are closing out at the Institute, so we'll be having them and giving them the opportunity to close out their programs in front of the community. So at this point, I'd like to thank everyone for coming on today. I would like to bring our moderator to the stage, if we could, and we'll get this started. Eric, you just should have to click on your camera.
How's it going, John?
There he is.
Can you hear me?
There you are, sir. Yep, we can hear you well. So we'll hand it over to you, sir, and you can bring the panelists to the stage and get us started. I would one quick thing, just so everyone remembers, especially if you haven't participated in one of these game days. It really, it thrives off of interaction. So we want you to, and really encourage you to ask questions. There is a Q&A button if you look on the right-hand side of your screen in that pane. If you click on Q&A, you can pose questions there. We also encourage you to vote questions up, and we'll try to make sure we're addressing those questions that get voted up by the community. There's also a chat function where you can find other folks who are here. So there's quite a variety of people who've called in today and will over the course of the next couple of hours. So if you're looking for somebody, you can direct message them through the system there. But really encourage you to ask questions and get involved. So over to you, sir.
Well, John, just one quick question. When I do need to bring the others onto the stage, do I do that, or is that automatic?
Yeah, it'll be done automatic. They'll be jumping on here in a second.
Awesome.
Thanks.
Okay, so I'm really excited about the panel session today, which I am sure is going to be thought-provoking and potentially entertaining. And we really have a star-studded panel of experts that live at that intersection of additive manufacturing and athletic gear. And really, in my mind, in the context of gear, the benefits of additive manufacturing are really twofold. And I'd like to talk about that today with the panel. But first, You've got mass customization, which allows for gear to conform to specific anatomy, like the head, the foot. But also, second, the big benefit is complex geometries, with spatially varying lattices that allow for the tailoring of, the dynamic, mechanical, response of a system to improve energy absorption, deflection. So I'm just really pumped to be here, and I think this is going to be a really interesting conversation. And so at this point, I want to go ahead and ask that the panel be added, and I'll go ahead and introduce the panel and ask each of the panelists to provide their background and involvement in additive manufacturing. Let's see. So I guess I'll wait until they come on board. All right, here we go. And I see Erika. So first on deck is Erika Berg, who works at Carbon in a company printing football helmets that have actually seen action on Sundays. And I saw Erika's keynote presentation at Rapid, maybe in 2019. I'm not sure, maybe in 2018.
Yeah.
When she described Carbon's collaboration with Rydell. So Erika, please tell us about your involvement in additive manufacturing.
Yeah, thanks, Eric. My name is Erika Berg, and I lead the business development team at Carbon. So I've been there for a number of years, and as Eric mentioned, I led the Rydell program from first engagement through to launch. So very exciting program. My background is in engineering and consulting, and so it was a perfect mesh of partnering with a customer to help them understand how to incorporate additives into their products, even though they decided to not get a printer and use the printer themselves. They partnered with us to say, how do we bring improved products to market? And that was such an incredible exercise. And from there, I have grown a team to look at an entire portfolio, primarily focused in elite athletics, but we're looking at across products. And love my job at Carbon. Would love to connect with anyone in the audience who is interested in potentially bringing DLS into their products and their applications.
Awesome. Yeah. So one quick comment would be that you're talking about elite athletes. At some point, I need to get a common Joe like me needs to get some cool gear for sure. But
absolutely.
So next, right.
Yeah. We're working on that. We want to drive innovation to as many people as we can. Absolutely. So, we're starting with the premium products, and we're absolutely building out. And I think even Thierry will talk about how we're doing that with CCM.
Awesome. So Thierry Patel is the next one I'll introduce. He's from CCM Hockey, a Canadian company that's well over 100 years old in the production of hockey equipment. So Thierry, if you want to give us a little background on yourself.
Yeah. Hi, everyone. I'm really happy to be here. It's really exciting and interesting to see all of you. So I'm the Advanced Design Manager at CCM. My role is to translate the user and science data into products. So I'm an industrial designer. That's my background. And I'm doing sports products from the last 15 years. So I've been into that industry for a long time. I'm really an advocate of user-centric design, and that's what I fight for on a day-to-day basis. And that's basically what led me to additive manufacturing. Because the properties of additive manufacturing, as you said earlier, Eric, are really linked to the user, like the geometries we can do, also the customization we can do with it. It's that's why I was really interested into that technology. I've been working with Carbon a lot, and we have a really interesting collaboration together. So yeah, that's about it.
Well, I'm excited to hear about the project, and we have a little video, I think, in a couple of minutes. And of course, Jim Sauerbaum, you're also with Carbon, and you were involved with CCM. So I'm really pumped to hear about what you guys are doing. But Jim, yeah, tell us about your background.
Yeah, well, great to be here and get to meet everybody that's participating today. My background is a little bit unique. I haven't been in engineering or manufacturing. I actually came from healthcare. So I was in healthcare for about 10 years, really on the technology side, whether it was implementing new systems in health systems or partnering to integrate systems together to then bring to a new health system, which was a big world for me for about 10 years. And then about 2 years ago, I joined Carbon and continued on that B2B phase to actually find out what is the problem that a lot of brands are facing in their product development and their manufacturing, and start to help them realize what's possible using DLS and 3D printing. So I've had the pleasure of working with CCM kind of from really when I first started at Carbon, as well as many other brands that are working on some really kind of unique things behind the scenes that we really can't wait to share once we're able to. Awesome.
And then, yeah, so I'm so excited to hear about what you guys are doing. And then finally, I'd like to introduce Dr. Jeff Crandall, who is at Biocore LLC. He's a professor at the University of Virginia, and he serves as a consultant for the National Football League. Dr. Crandall wants to present some slides to give some of the details relating to athletic head injury and how additive manufacturing can make a difference. Dr. Crandall, please tell us about yourself and let us see the.
Yeah, so first I'll give you a bit of background, and then we'll see if I'm successful in sharing the slides. We've been struggling this morning, but I think, as Eric said, I chair the NFL Engineering Committee, and our role there is really how do we take engineering and apply it for injury prevention strategies. And so equipment that we're going to talk a lot about today is one of the key cornerstones, but obviously, we also have to look at other avenues, education, as well as enforcement, as well as rules. So it's fairly comprehensive. We do head to toe, and I'm going to try sharing. I see Andera's got some slides up. Let me see if I can share some of mine. I may not be able to. So Andera, you're sharing?
For you, Jeff.
Okay. So hopefully everyone's seeing that. So what we're showing is a slide of sort of the injury prevention work we do in the NFL. If you look over on the left, you see we've got a player there, and that's to remind me to tell you that literally we study injury prevention from head to toe. So everything from helmets to cleats to infrastructure like turf. If you look sort of on the on-field injury tab up there that Andera is sharing, one of their key things or cornerstones of what we do is let's understand what's happening on field. So every year we literally look at thousands of injuries that occur from head to toe. We look at tens of thousands of non-injury events because we want to make sure that we understand when players are injured and when they aren't. One of the cornerstones, though, is not just looking at these and saying the when, what, where, how, and why, but we need to get quantitative. And so there's a big part of what we do is measuring what happens on field. So we show up there, we've developed some MEMS sensor technology that goes in mouth guards that tells us head kinematics. The NFL has player tracking data, both in practice as well as games. So we know accelerations of the body, we know velocities, we know distances. And then a lot of what we've been working on is we sort of take a data analytics approach now and machine learning, and we do a ton of computer vision. So we look at things like pose estimation, we track helmets, we track shoes, we say what angle was that knee bent at from video, and we do that automatically. That's one of the big things that we've gone to, is doing it at scale so we can track each and every player on each and every play. Then I think more of interest to this community is how do we take that information and how do we share that with designers and innovators? And so what we've done is take that quantitative information and said, let's reduce the very complex on-field environment to a laboratory setting. Let's give the people a test that they can design to. And so there's an example there of, we developed a pneumatic impactor within the NFL that's now become an industry standard that allows us to replicate the sort of head motions that occur. On the lower right there is a turf tester. So we can actually push a cleat in at the right orientations, the right forces, and twist it within the turf. And then we can say, hey, which turf appears safer? Which cleats are safer? And then I think on the tools there is we recognize that I think that up until, say, the last few years, a lot of sports equipment had not been sort of state-of-the-art, commensurate with, auto safety or aviation or aerospace. And so we said, what tools can we provide to these entrepreneurs that are trying to design to that test methodology? So we reversed engineered helmets. We linked them with all the state-of-the-art biomechanical models. So we can tell you, if you've got a helmet design, not only can we tell you the head acceleration, we can tell you what the brain strain is. We can tell you what the probability of injury is. And so you can incorporate that. And so we've gone with a computational framework now for helmets. Shoulder pads are shown there, as well as footwear and turf. And I've got just one more brief slide that sort of ties in more for the discussion today. If you can go to the next one on, Dara. Maybe. The next one that I wanted to tell you about, there it is. And the way that ties into this community is we recognize that there's been significant progress in the last few years on helmet design, and some of that you're going to hear about today. But we want sort of the next generation. We want 15, 20, 25, 30% improvement from where we are right now. Sort of what I would call revolutionary progress, not evolutionary. And so we've got a helmet challenge. It's a $3 million challenge. Prototypes are due next June. And I think we knew there were opportunities for additive manufacturing in this. So we did a kickoff meeting in Youngstown last year with America Makes. And the idea is develop a prototype that uses these tools, uses these tests, and it significantly advances safety. And on the bottom here, I've got one final parting thing, which is we looked for folks that had that were starting out that needed seed money to get ready for this helmet challenge. And we had 100 submissions. We chose 4. And the important thing to show here is that all of those 4 used additive manufacturing. They all used a computational framework. They all used collaboration, universities, large chemical companies, additive manufacturing. And that's exactly what we think is needed. So there's a brief overview for you, Eric, and I'll let you get back to the rest of this.
That's fascinating. That's just so exciting. So, okay, so the next thing I want to do before we really start the panel discussion was we were going to show a quick video that will talk about the CCM helmet. So on Dara. Awesome. That was extremely cool. So start the panel. I just want to quickly make some announcements and guidelines for the audience. If you have questions or comments for the panel session, use the chat feature or the Q&A feature to communicate with us. And if you don't have comments, of course, you can still influence the voting questions. And the panel has asked that we start with posing 3 questions to the audience to consider and ruminate on during the panel session. And we ask that the audience provide that feedback through the chat feature. And as comments arrive, we'll integrate that into the conversation. And the 3 questions that were being asked of the audience are, what are the biggest concepts you and the audience see as required to improve products in athletics that the additive manufacturing industry may not be currently considering? Number 1. Number 2, to further the next generation of energy management products in the context of impact, what data needs to be captured and analyzed that hasn't been considered yet and should be? And then finally, mass customization, personalization of products is a major benefit for companies starting to leverage additive manufacturing. However, additive can be maybe a daunting process to integrate into manufacturing and design workflows. So the third and final question is, how can the additive manufacturing industry help enable the personalization in your brands and products? And so think about those, and we can, bring those in from the chat as we go. So now I'd like to start with the discussion, and I'd like to throw out the first question, and we'll take questions from the audience and have the panelists discuss this. But the first thing I'd like to ask is, well, beyond the helmets and shoes that we know about, and which have been the primary focus, are there other application opportunities for protecting the health, 1, and 2, improving the performance of athletes? And what does the panel believe is like the next killer application? And I guess we could, we ended with Jeff, so maybe we could start with Jeff on questions, and we'll just go round robin.
I think it's a good question, Erika. And one thing I would say is you listed sort of helmets and footwear as areas that are already being addressed. And what I would say is that cleated footwear, which obviously a number of sports utilize, has not really been addressed. You saw Nike sort of dabble around 2014 in 3D printed cleated footwear. But I think there's huge opportunities. If you look at the NFL, the number one concern of players, our number one burden, our number one frequency is lower extremity. And if you look at footwear, it really is not where it needs to be in terms of cleated footwear. It's the number one complaint of players. Their feet roll off, they don't fit well. And to give you a little bit of a history lesson here that I thought of is, we measure shoes actually in sizes based on barley corns from the 14th century. And so if you want to talk about an opportunity for customization, modernization, I would put footwear still up there. But of course, body pads, shoulder pads, bracing, all kinds of countermeasures. But I think for us, I would advocate for still sticking with footwear because I think there's opportunities.
Awesome. Well, then let me, I think, Jim, you were next in line then. Do you have some insights or comments?
Yeah, I mean, I think really when we're thinking about elastomeric lattices, we're really thinking about how does that manage energy in a way that foam is kind of being replaced in. So when we're starting to have these conversations with these brands that are looking to get into additive, it goes right to the foam properties that they're limited by and where those foam applications are being used on the body. So I think padding in general, whether that's head to toe padding, is going to be a real explosion in this area from both an improved performance standpoint, but furthering down that customization path. So I think we're really just kind of at the tip of the iceberg, or the top of the human at this point for doing that. And there's so much more space for us to travel into.
Awesome. That's really cool. And Thierry, you want to add to that possibly from the hockey standpoint?
Yeah, well, I don't want to talk too much about that. There's a lot of interesting stuff happening for sure on our side, but there's on our side there's still a lot of interesting thing to improve in the helmet field. I think there's head injury is a big thing. It's a big problem in sport right now. Not only in football, it's the same in hockey. So there's still a lot of work to do. And we're putting a lot efforts and design intention into that field. And the helmet we launched lately is a great success, and we want to build on that foundation for sure.
Cool. And Erika, how about you?
Yeah, I'm gonna build.
Oh, you're muted. I think you're.
Can you guys hear me now?
I can hear you.
Okay, I can hear you now. Sorry.
Okay.
It was a delay. Sorry.
No worries. I will build on what a number of the other panelists said. I think, in the last decade or so, we've really moved to certain expectations of on-demand. You order something and you expect to get it within 2 days. And I really see that next frontier to be on-demand, quick, but also for you and custom. So I think that's really what we're going to push. And I'm so excited to be partnering with companies that are helping us push those boundaries. And as you were mentioning earlier, Eric, an average Joe wants to get a custom helmet. People want custom products and they want it their way. It's not just immediate, it's immediately for me. And I really am excited to be helping chauffeur that along.
That's awesome. So yeah, the average Joe, not an elite athlete. I can't wait.
Right.
Well, great. Yep. Those are great answers. So a second question, and then maybe we'll start looking for the audience if they want to add some. So one thing that strikes me is that commercially available 3D printed shoes, right, are really a testament to the durability of these next generation materials that are in 3D printing, particular the elastomers. Is there any insights about, breakthroughs that are imminent that could further enhance athletic gear, maybe in the outer shell or better elastomers? Is there anything you guys would want to mention there? And I guess we'll go in the same order. Dr. Crandall, if you could tell us what you're thinking.
I hope so. I'm sort of the end user here, and I hope they've got things in the work stream. What I would say is, we do a lot of optimization work where we just look at, given an available space, what could be achieved for energy management. And I think I realize it's a combination of structures and materials, but based on what we've done analytically, based on what we do computationally, we see lots of opportunities for improvement. I think the other thing I'd like to challenge them to is we see a lot of work on improving upon materials and current design concepts. I'd like to challenge them and the manufacturers and say, think outside the box, because I don't think we're in an evolutionary design point where the current helmet has to look that way. I think with new materials, new structures, we're replacing components, improving them drastically. But I think, again, computationally, we see opportunities where the helmet with 3D printing doesn't necessarily look like the helmet that we've got today. So
that's fascinating. But it still needs to. If you do change the form and make the helmet super big, I think the mirror test has to be there.
Absolutely.
Yeah, Jim, what do you think?
I think it's a great point, and I remember early on hearing our co-founder Phil talk about some of the different durability tests that materials were going through, and one of the points was these midsoles, they can last forever in some cases. How do we make sure that the materials are designed to what they actually do in addition to durability? So from our standpoint, part of it is also looking at tuning those materials to be more specific to the profile that you're looking to achieve out of it, whether they're energy damping or energy return in their bulk properties. Learn from that cycle and then figure out what the customer values most out of it and continue to refine that formula to get a better performing, better energy damping material that maybe next version is lighter weight. Maybe next version is offering different colors is something that we hear about quite often. But I think beyond kind of the space that we're currently kind of showcasing products is where we want to see materials go is kind of elevate us to that very next level of competition. You start to think about some of the sports that really focus on body protection and head protection that are beyond me hitting my head against the lineman 60 times a game and me driving a car as fast as I can and trying not to hit a wall. How do you make material breakthroughs that can compete with the World War II foams that do a really great job of what they do at a great price point and lightweight. How do we incorporate those aspects of a product into something that is highly engineered, both from a structural standpoint, but also a material standpoint? And that's where I'm really excited to see the materials kind of roadmap and development go as additive pushes further into athletics.
That's fascinating. Yeah, the color, that's a good point. I didn't think about that, but that goes back to Jeff's mirror test, right? You might feel like you look better in black versus Thierry, what do you have on the hockey perspective?
Well, it's the same. The mirror test is a Petelle, and it's to be honest with you, there's a lot of element molds in somewhere in the ocean because they failed the mirror tests, right? There's it's so important, and that's where like that's probably the most obvious intervention of the team of designers, right? We have to make these things accepted, but meanwhile we have to make them innovative, and we have to make them look more advanced in a way. So for sure, as Dr. Crandall said, we have it has to show these technology can give us new opportunities, and we have to build on that. It's a very, very, very tough challenge, but that's something we work on a daily basis.
Definitely. Erika, what's your take?
Well, I think we're certainly always looking at advancements in materials and what can we do to constantly innovate and improve and evolve in the great materials that we already have. What I think is very interesting and unique to our technology at Carbon is the way that we incorporate software to be able to change the response of the materials and really control the energy. And so we can take something that's one material and open up an entire spectrum of responses and feel based on the software and the way that we design that material to respond. So I'm really excited to see how we push software innovation to change the designs of and almost make smart materials, right? Because you have a material that is designed to respond closer to your head or closer to your body to feel comfortable and soft, but then provide that impact resistance and energy dissipation that you want when you go through an impact or something happens, but also be able to have that resiliency in the way that it's designed so it pops back and maintains that form to keep a structure that you want. So I think the software is something that is equally as important as what the material is how is it designed and how are you using data to really drive that innovation.
Yeah, so kind of at a macro level, you're changing the material by changing a lattice and so forth.
Exactly.
That's just so cool. Okay, so yeah, this is absolutely fascinating. So next question would be maybe related to that. If 3D printing enables new complex geometries to tailor the mechanical response, can you comment on any breakthroughs maybe in design or geometry that could further improve athletic gear? And I think, Erika, you just kind of answered that question, but is there specific breakthroughs or can you comment on anything that we should be looking for in the next 6 months, 12 months?
Yeah, well, we recently made available our design engine. And so this is where our customers can come in and design their own lattice structures using the tools that my team gets to use internally at Carbon. And so those breakthroughs in software, I think, are really what are going to push further innovations with the existing product suites that we have. So I'm excited to see that software continue to evolve and meet the needs of our customers. That's the main thing that I'd like to bring up right now. Yeah.
Yeah. So as a professor, the first thing I've got to ask, is there like a university discount to get this software? Or okay, yeah.
Yeah, we can. We'll figure something out, Eric. We'll figure something out.
All right, I'll go to Jeff then. What do you think about the idea of design, geometry? Is there anything that you see?
One of the challenges we see is, you know, many parts of the body are deformable, and we see that there's surface geometries. And so I think, you know, there's a lot of interface characteristics. I know hair has been a challenge, for example, where 30% of our players have hair that, you know, exceeded, I don't remember whether it was a half-inch standoff or what it was, but it makes challenges. And I think as we migrate to other parts of the body, foot scans, for example, if you had a Brannock measure your foot, you get something different than a foot scan. Or we're scanning for body padding, and there's working on 3D printed, but how do you address that human interface? So there's a complexity there about the interface, and it changes with mobility and motion. It changes. So I think one of the challenges I would like to see is how we incorporate sort of the biomechanics, the anthropometry of the body in a dynamic sense into the design process.
Yeah, so that's fascinating too. It's just the organic nature of the human body, obviously, with hair and the ability to be flexible. That makes a challenge from the standpoint as an engineering professor. I like to think of geometry as sort of static, but that's just not appropriate, I guess. So yeah, very good. Jim, I know you're working with the Carbon software, so you probably have some innovative insights.
Yeah, I mean, I think Erika kind of hit the nail on the head from the Carbon perspective of the design engine. But I mean, really, when I think about it, it's getting that design engine out into the hands of these customers, because we go through these development cycles and you've got so many different parameters that you can change in the structure with a certain amount of resources to go ahead and do that, marching up to a launch date. The more users getting their hands on this, just the more iterations that tool we believe is going to output. And we're just going to learn so much more about those mechanical responses outside of simulation and into real world.
Yes.
So I think that's a big thing that we'll start to see customers kind of realize using that software. And then I think the other thing too is just we're always learning more and more about lattice. And a lot of what you see is what we refer to as strut-based lattices. And you've got your strut diameters, your cell sizes, your cell shapes as kind of like your general parameters to pool with. But as we kind of study lattice even further, we're learning more about surface lattices, which tend to be studied in science as higher strength to weight ratios. And how do you start to incorporate those into padding? And that's kind of another frontier that we're really starting to understand and hoping to push forward to bring these products to our customers. So I think getting that design engine out is key, but we'll be continuing to study kind of the newest things that the PhDs are working on in the universities to help us understand how does nature deal with energy, and how do we incorporate that into the tools that our customers can use. Yeah,
that's okay. So one takeaway for me is that maybe the software for generating these designs is pretty powerful, but we haven't just explored it enough. The software that exists, and you need more people, broader adoption, more iterations to explore a wider space of geometry. I think that's really cool.
Exactly.
Oh, you're muted. Yeah, there you go.
Again, I'm no complex geometry expert. It's not what I do. I'm not a CAD guy or mechanical engineering or a math guy at all. But I would say that I understand the complexity and the depth that lattice structures and geometries can give us. That's why additive manufacturing is so interesting. There's no one silver bullet in this thing. It's a wide array of solutions that can be customized and personalized to everyone. So there's the question is any breakthrough in design and geometry, it's a big learning curve. We're learning a lot, and it's by doing the iterative process of prototyping and testing that we get to better solutions and improvements.
Yeah, so it's a simultaneously looking at many different aspects or benefits that 3D printing can do, geometry, materials, and so forth.
Exactly.
And then, yeah, that's very cool. Okay, so I've got another question, and this one's kind of, I guess, the most interesting to me because it's sort of near and dear to my heart. But, you know, in the general additive manufacturing research world, there's a lot of research that goes on about embedded sensors, you know, microcontrollers, intelligence, actuation, and also in related would be like advanced thermal management, which are both really hot topics in additive manufacturing. Do you guys see those general additive manufacturing concepts, research concepts that are at the vanguard? They're not, you know, in production today, but is it an inevitability that those concepts or others will be introduced into the equipment that you guys are designing and fabricating? And I guess, Dr. Crandall, can I start with you? Back to our original order.
You like starting with me. I think the answer is certainly. I think as you saw, I mean, we're continuing to embed more and more sensors. The more information we have about what the athlete experiences, whether that's mechanical loads or thermal loads, the better we can tailor equipment. And I think one of the questions that would be is, are there opportunities, Erika touched on it, but are there adaptive opportunities for either thermal management, for impact? You know, you're talking sub-milliseconds response, so I don't know exactly what you do, but and then I think one of the things you didn't mention, Eric, but would be communication. You know, for example, an alert. Do I have a blind spot? Can I put a route up there? Can I communication between coach and player now is an add-on to helmets? So I think electronics even broader, tremendous opportunities to embed those in the mechanical structures. So
that's, yeah, pretty interesting. See, this might be cheating in the football, but if you were to potentially have like a vibration on different parts of the head, you might know that you're about to get tackled. You know, sort of like my car tells me when I'm about to run into my mailbox.
Exactly. That's the concept. So
very cool. Very cool. All right. I think, Jim, you're next.
Yeah, and I think that would be really kind of interesting to see come to life with the customers using this type of technology. I think from Carbon's perspective, we want to be accommodating to as much as we possibly can for our customers' requests. We're not necessarily studying that field of embedded thermal sensors or different types of sensors inside of the products, but we are studying how do we accommodate those types of things if a customer is looking for that. So I think we would certainly welcome and encourage that inclusion because it's just going to make a better process or a better product for that customer ultimately once they've got the data to understand this part of the impact and this part of the situational awareness. How do we incorporate that into the final design of the product going on the field?
Awesome. Thierry, have you thought about that? I mean, this is kind of wacky academic research that I'm talking about, but it seems like it's an eventuality that it will be introduced into these products.
Well, yeah, it's a very interesting topic to be honest with you. Yeah, so when we started that helmet project with Carbon, to be honest, like thermal management was not at the top of our list. It was maybe a nice to have or an interesting thing to research. But as we were developing the helmet, I really remember that the first time we received parts and we tried it in a helmet in a hockey game. Remember that was a pre-COVID era, so we were to do things outside of our home. So when we received that helmet and we shared it and we were trying it and we realized that there's a super interesting benefit there, and an interesting benefit that could be like at some point even as important as the other properties we were looking for. So yeah, it's really you can feel it like for the user. It's a really obvious benefit. Yeah.
Interesting. Yeah. In the thermal management for sure. Erika, I don't know if you can answer this question. I understand you have to take a flight, so you might have to leave us, but.
Yes, unfortunately I do, but I did want to answer this last question. And I think what's really great about additive manufacturing is you can almost always be in eternal state of beta. And so by designing sensors into a component, again, leveraging what I was talking about earlier about almost transforming a material into a smart material, with those sensors, you can then take that data, that feedback, improve the design, ensure that you're always providing the best product and the best results to each athlete and player using whatever product based on the data that comes out of a sensor. And so we can be in this eternal state of improvement and agile iterations because the parts that we make come out final finish ready parts. You can iterate on the fly. You can really make improvements